Okay, so that last lesson was about negative feedback. Let's remember what negative feedback is. Negative feedback is when any change that occurs gets reversed back to the set point. If a change occurs, it gets reversed back to the set point. So we looked at the example mainly for reproductive hormones. We looked at estrogen. Estrogen's a brilliant example. It's one that examiners love to use, and that is simply because when estrogen levels, when FSH levels are rising, so there's the change, the FSH levels, you can see they're rising away from their set point. Estrogen gets involved and brings them back down to their set point. So it's a lovely example of how one hormone can control the levels of another using negative feedback. Estrogen feeds back onto the pituitary gland to stop any further production or secretion of FSH. It inhibits FSH from being released. It's also a fantastic example of positive feedback. And you can see here that when estrogen reaches its peak, it causes for further and further and further and further release of luteinizing hormone. So you can see it's deviating further and further away from the set point. So that's positive feedback. So it's a really good example to use. We also talked about in our last video blood glucose. If the blood glucose levels change, so if they get high and they're increased because you've eaten a meal, that's when your hormone insulin will reverse that change. Negative feedback, bring it back to the set point. If they fall too low, our blood glucose levels, how do we reverse that change? It's going to be glucagon having negative feedback. Okay, but I'm going to talk about two different hormones now that you need to be aware of. And these hormones are TSH, which is a thyroid stimulating hormone. And I'm also going to talk about the hormone thyroxine. These are two very important hormones that you need to be aware of when talking about negative feedback. So you need to know, as with all hormones, where they are released from. So where is estrogen released from? The ovaries. Where is FSH released from? It's a code. The pituitary gland. Where is insulin released from? The pancreas. Okay, so you need to know the same for these. Now, thyroxine, just like the name suggests, if you think back to your head, shoulders, knees and toes song that you had a lesson on quite a while ago, you've got pituitary, thyroid, adrenal gland. So we're going to draw our thyroxine. It would be the thyroid gland. So that you'd find in the neck. Yes, I realise how that looks. So here's our thyroid gland. That is what that is. Thank you very much. And where do you think TSH is going to be released from? It is a code. What decodes things? It's our brain. Oh dear, which seems to look like a fluffy sheep. So it is our pituitary gland. My art skills have clearly improved. Okay, so why is thyroxine really important? It's a hugely important hormone that is responsible for controlling your metabolic rate. And what that means is the rate at which you break things down, build things up and break things down. So really we're talking about rate of respiration here. That's what we're talking about when we're talking about thyroxine. It's going to control your metabolic rate. So it's very, very important for development and growth. It's going to allow you to release lots and lots of energy. So if we're talking about negative feedback, we've got to go back to that little graph that I talked to you about. So here's my set point, my constant internal environment, whether that's my internal temperature of 37 degrees, whether that's my blood glucose concentration, is my set point. And you've got a set point of thyroxine. It stays pretty much stable the whole time. And so homeostasis is important for maintaining those levels of thyroxine at their set points. So if thyroxine, which is nice and stable, starts to drop, if my levels of thyroxine start to drop, and thyroxine, we make that hormone from the iodine in your diet. If you haven't got enough iodine in your diet or something's not quite right, and they start to fall, these levels of thyroxine, then this is where it is detected. Remember, there's a change. There's your stimulus. It's going to go to our receptors, which are going to detect that change. And it's receptors actually in the pituitary gland that are going to detect that change. And this is where TSH would now be released from the pituitary gland. So TSH would now be secreted because that drop in thyroxine has been detected. And the TSH, as the name suggests, the thyroid stimulating hormone, stimulates the thyroid to do what? To release thyroxine. And by releasing that thyroxine, TSH has done its job, starts to release the thyroxine, which brings it back up to its set point. Now, if it starts to go above the set point, all that thyroxine, as it starts to increase, will negatively feed back on the pituitary gland and stop any further release of TSH, allowing it to stay at its set point. So you've got two lovely examples there of negative feedback. The thyroid stimulating hormone, as soon as those thyroxine levels drop, we've got a change. Remember, negative feedback is a reverse of a change. If the thyroxine levels fall, TSH, the thyroid stimulating hormone, will reverse that change by stimulating the pituitary gland to secrete thyroxine. Remember, this blue line is thyroxine. So thyroxine increases, but if we get too much thyroxine, it's the thyroxine level that actually stops any further production of TSH, allowing it to stay at its set point. Aren't our bodies amazing?